Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Welcome to Lesson 17, Slicing a Right Rectangular Pyramid with a Plane. Classwork opening, rectangular pyramid. Given a rectangular region B, right here, in a plane, E, and a point V not on or in E, so it's up here in space, the rectangular pyramid with base B and vertex V is a collection of all segments VP in B. It can be shown that the plane region defined by a side of the base B and the vertex V is a triangular region called a lateral face. Okay. So what they're saying is, if you take line segments anywhere from B and draw them up to V, you're going to get a solid figure in the shape of a pyramid. The rectangular pyramid is determined by the collection of all segments VP for any point P in B. So any point on B anywhere, it can be interior or on the edge. Here VP is shown for a total of 10 points. The rectangular pyramid is a solid once the collection of all segments VP for any point P in B are taken. The pyramid has a total of 5 faces, 4 lateral faces, and a base. So the bottom is the base, and each lateral face is what they call a lateral face. Lateral meaning side. So the sides, there are 4 sides. Okay, so there's the explanation of the formation of a rectangular pyramid. Okay, page 2. If the vertex lies on the line perpendicular to the base at its center, okay, so let me say that again. If the vertex, V, that's right here, lies on the line that is perpendicular to, see this right angle right here? So this is a straight line down. So if you think of a tent, this is the pole in the center that holds the tent up. The intersection of the rectangle's diagonals. Okay, so if the vertex lies on the line perpendicular to the base at its center, in other words, if it landed right here, where the base's diagonals intersect, the pyramid is called a right rectangular pyramid. In other words, this V would be directly over this. It would be straight up from here. But this one is tilted a little. So here is an example of one that is a right rectangular pyramid. The example of the rectangular pyramid above is to the right here is not a right rectangular pyramid, as evidenced in this image. The perpendicular from V does not meet at the intersection of the diagonals in the rectangular base B. So this line segment that comes down from the vertex to the base at a 90-degree angle is offset from this center here. So it pushed the top over, making this side steeper and this one less steep. The following is an example of a right rectangular pyramid. The opposite lateral faces are identical. They are isosceles triangles. So all 4 sides, when it's a right rectangular pyramid, are identical, forming isosceles triangles for their sides. Okay, so example 1 says, use the model you built to assist in a sketch of a pyramid. Though you are sketching from a model that is opaque, use dotted lines to represent the edges that cannot be seen from your perspective. Okay, so your sketch will vary from mine. Okay, so first of all, I need a rectangle for a base. So I need to start by drawing a rectangle. Actually, I would want mine. Yeah, let's do this. Okay, so here is my E. Okay, I redrew mine so it looks like it's offset a little bit. All right, so here is, first of all, we need a plane. And we're going to call the plane E. All right, I want a rectangle on E. So I'm going to do the same thing again. Choose a shape, and this time I'm going to make it thinner. Actually, I don't even want to do that. Let's use this segment, and let's do orange. Okay, so obviously I can see the front. So if I draw this over like so, there's my front. And then if I draw this over like so, there's my right side. Okay, I want that turned a little bit more. Like that. Now, if I draw one over here, and I'm looking at it from this direction, so I'm right here, looking this way, I can't see this side over here or this back side. I'd have to walk around this side to see it. So what they're saying is, when you draw those sides, you want them to be dashed to show that you cannot see it, like so, and then over to here. All right, so now I'm going to put a point up in space that I'm going to call V. I'll put it, say, right here. Okay, so I put the dot there. I'm just going to draw a regular pyramid. It doesn't have to be a right rectangular pyramid. It didn't say. It just said the sketch of a pyramid. So now I want to draw my segments, and I will do those in green. From this corner, I would be able to see it, so it's going to be solid. So there's my segment there. I'd be able to see this one as well. So there would be my right side, or my right lateral face. And then if I drew a segment up from here, I'd be able to see this corner from this perspective. So now I have the front lateral face. I would not be able to see this back side. So if I drew a line segment, oops, I thought I turned it green. From here to here, I would not be able to see it, and therefore it is a dashed line to tell my reader that we are looking through it, okay, if it were opaque. All right, so is this a right rectangular pyramid? So what I'm going to do now is draw a line segment straight down, like so. And then I'm going to draw an X. In other words, I'm going to draw diagonals from each corner. And as you can see, let me just move this one a little bit. My vertical line from my vertex down to the base to form a 90-degree angle is not right here at the intersection, so therefore this is not a right rectangular pyramid. Okay, so there's the sketch. Okay, page 3, example 2 says, sketch a right rectangular pyramid from 3 vantage points. From directly over the vertex, so we're looking down from it, so if we were a bird flying over. 2, from facing straight on to a lateral face. And 3, from the bottom of the pyramid. Explain how each drawing shows each view of the pyramid. Okay, so if I were looking straight down on it, first of all, I need a rectangular base. I'll draw that like so. Okay, so there's my base. Now remember, we're looking down on it from straight up in the sky. So if I put my center, my vertex here, I'm looking straight down at it. Now I need to draw segments that go from the vertex to each corner. Okay, and there's what it would look like. Okay, so those are the four sides looking down at it from the sky. Okay, so it would look like this right here. Okay, example 2. I want a right rectangular pyramid. This time, I'm looking at it from directly in front, from facing straight on to the lateral face. So, I'll make this one, I don't know, green. So if I'm standing, now it'd be like this. Now I'm going to be over here, looking at it from this point of view. What would that look like to me? So here's what it would look like. Here's the front. Here would be the vertex, the top here. Okay. And we might be able to see some of the side like so. Possibly. It might look like that. So if we're, ooh, that was bad. All right, let me fix these lines. Okay, maybe like that. Okay, so looking at it from this point of view, depending on how far away we were, this might be what it looks like, but we might only just see the triangle. Okay. All right, and then looking at it from where? From the bottom of the pyramid. So let's just say this was a model of a pyramid, kind of like a Rubik's Cube, but only a pyramid. What would it look like from looking at it from underneath? Well, that's easy. Then it would look like this. Okay, and we wouldn't see any of the sides. It's just be a solid bottom rectangle. Okay? Example 3. Assume the following figure is a top-down view of the rectangular pyramid. Make a reasonable sketch of any two adjacent lateral faces. What measurements must be the same between the two lateral faces? Mark the equal measurements. Justify your reasoning for your choice. Equal measurement. Okay, so I know it's a rectangular pyramid because this side just appears to be longer than this side. So I will just outline this side in red, and that's going to be the first side I'm going to do, and I'll do that in red. Let's make it thinner though. All right, so that's what it would look like. And then if I do a dashed line down the middle to show our perpendicular, like so, then that forms a right angle right here, and these two sides have to be congruent. So that would be this face right here. Okay, so that is wider than this. So now if I do this side in blue, this one here in blue, then it would look like this. Okay, switch to blue, switch to thinner line, and it would not be as wide, so I'm going to make this base shorter. It should be the same height, so I'm going to put that like right here and come down like so. And why did that go away? And up like so, and then my vertical line that is perpendicular. Just need to move that over just a little bit. Okay, maybe right there. Okay, and what do we know about those sides? Well, first thing I know is this is a right angle, and this side is the same length as that side. Okay, and I don't want to put 2 marks there because they should be the same as these, right? Because it's the same height. Or are they? Maybe not. But anyhow, in looking at just the triangle, these two would be congruent. So the equal sides in each triangle are the same between both triangles. Okay, they would be the same. This equals this equals this equals that. Okay, page 4. Example 4. A slicing plane passes through segment A. Here's segment A. Parallel to the base B of the right rectangular pyramid below. Sketch what the slice will look like into the figure. Then sketch the resulting slice as a 2-dimensional figure. Okay, students may choose how to represent the slice. Example, drawing a 2D or 3D sketch or describing the slice in words. Okay, so let me switch to red since they've already started in red and do a thin line. And we're going to do a segment thin in red. All right. So they gave us this here. That is going to continue over this way, parallel to the base. This is parallel to this. It is also going to continue from back here over to this side, parallel to this back base. And then finally, it's going to finish by coming over like so. So there is our slice, if you will. Okay, we're going to cut through this. So if this were made of clay and we decided to take a knife and cut through, there is our slice. Okay, so there it is shaded in. And then finally, what would that look like looking straight down on it? Okay, well, it would look like a rectangular. It'd look like a rectangle. And okay, so there we go. Struggle a little with the stuff, and I didn't need you to see that. So there we go. There's what it would look like looking straight down on it. The slice is a rectangle, and it looks a lot like a rectangular base, but it is smaller in size. So it's similar. It's going to be similar to the base. B says, what shape does the slice make? Okay, I just answered that. It is a rectangle. What relationship between the slice and the rectangle base of the pyramid? And it is. Okay, so the slice is a rectangle. The slice looks a lot like the rectangular base, but it is smaller in size. Okay, page 5 brings us to example 5. A slice is to be made along a segment A, as in the first diagram, perpendicular to the base B of the right rectangular pyramid below. So now we're slicing straight down, not straight across. Which of the following figures shows the correct slice? Justify why each of the following figures is or is not a correct diagram of the slice. Okay. All right, so we're starting with this. This is the mark, so we're starting here. We're cutting straight down. Is this the perpendicular slice? And the answer to that is no. And the reason is that this would have to come... Hello, I turned you to green. Why are you ignoring my request? Green. So you would have to come over all the way to here and cut this out. So it's missing all this piece here on both sides. So, no. The slice doesn't cut to the edges. Okay? All right, this one, definitely not. This is not perpendicular. Okay, this is a lateral, this is just like putting a tarp on a roof. That's just a lateral piece. Okay, this is just a lateral face portion where it lies. Okay, and this is definitely the slice that we would make because we're coming all the way over. So I kind of explained that here. That's what was missing here. And there it is right there. So this is a slice made by a plane meeting the rectangular pyramid perpendicular to its base. It shows all the possible points at which the slicing plane would make contact with the right rectangular pyramid. The slice is in the shape of an isosceles trapezoid. Okay? So there is problem number 5. A. Okay, page 6, part B to number 5. A slice is taken through the vertex of the pyramid, which is right here. Perpendicular to the base, sketch what the slice would look like into the figure. Okay, so if it's perpendicular to the base and it's going through the vertex, it would meet at the midpoint of both lateral sides. So I am going to do this in pink, and I will do it with a thin line. And so what I'm going to do is go from the vertex down to this edge right at the midpoint. And I'm going to do the same thing over here right down to its midpoint. And then I'm going to slice it from this midpoint all the way through like so. Now I just need to adjust this a little bit. I'm not at the midpoint. Okay, it's more like there. More like there. Okay, so there is my slice. Now I just need to move this up to here. There we go. And this to there. Okay, so there is my lateral slice. And then when I shade it in, okay, so here's what the lateral slice would look like. And then I will do what would it look like in 2D? All right, so it would just simply be a triangle. Like so. And then shade it in. Okay, so there's what it would look like, slicing it through the vertex. Okay, page 7 brings us to the end of lesson 17. Review the lesson summary and go do your problem set.